Do you know what is the age of your smartphone, Bluetooth headset, camera, laptop, etc.? What fuels all of these devices? A battery serves as their power source. Welcome to the new episode of Viomology. In today's episode, we will talk about how old the battery of your gadgets is. The fundamental element of the battery is the lithium ion. And we are going on the fascinating journey of the origins of lithium. Let's embark on an extraordinary adventure to explore how this crucial element found its way to Earth. From cosmic origins to geological processes, we'll uncover the secrets of lithium's journey spanning billions of years. So, sit back, relax, and join us as we unravel the captivating story of how lithium came to Earth. Our story begins billions of years ago when the universe was a cauldron of nuclear fusion. Inside the heart of massive stars, hydrogen atoms fused to create helium, and in a cosmic chain reaction, helium fused into beryllium. The process continued until the stars could no longer bear the pressure, culminating in a supernova explosion. Nucleosynthesis occurred within the cores of massive stars. Through stellar fusion, hydrogen and helium fused to form lithium, along with other light elements like beryllium and boron. These primordial processes were crucial in seeding the universe with the elements that would eventually lead to the creation of stars, planets, and life as we know it. As stars aged and went through their life cycles, they continued to synthesize elements. This process, known as stellar nucleosynthesis, played a crucial role in the distribution of lithium across the cosmos. When massive stars exhausted their nuclear fuel, they ended their lives in spectacular supernova explosions. These titanic events released enormous amounts of energy, ejecting the synthesized elements, including lithium, into space. Now, let's explore how lithium became a part of our very own solar system. Around 4.6 billion years ago, a vast cloud of gas and dust, known as the solar nebula, began to collapse under its gravity. As the solar nebula contracted, it began to spin faster, and most of its material accumulated at the center, forming the Sun. Around the young Sun, a flat, rotating disk of gas and dust, called the protoplanetary disk, emerged. Within the protoplanetary disk, particles of dust and gas collided and stuck together through a process called accretion, forming planetesimals, which later grew into protoplanets. During this time, lithium, along with other elements, became incorporated into these growing celestial bodies, including Earth. Let's focus on our home planet, Earth. After the protoplanets reached a certain size, they began to attract more material through gravity, leading to the formation of the planets we know today. Earth's interior separated into layers, with the lighter elements, including lithium, becoming concentrated in the lithosphere, the outermost shell that comprises the Earth's crust and upper mantle. But how did lithium become concentrated in Earth's lithosphere? To understand that, we need to delve into the geological processes that shaped our planet's history. Over billions of years, geological processes like volcanism, weathering, and tectonic activity played a significant role in transporting and concentrating lithium in certain regions. Volcanic activity, for instance, releases lithium from the mantle to the surface, where it interacts with water and other compounds, eventually leading to the formation of lithium-rich deposits. As human civilization progressed, we discovered the usefulness of lithium for various applications, ranging from ceramics to batteries. Lithium's properties, including its high electrochemical potential, made it ideal for batteries, revolutionizing portable electronics, electric vehicles, and renewable energy storage. Our journey to uncover the origins of lithium has taken us from the cosmic crucibles of nucleosynthesis to the geological processes shaping Earth. We can conclude that the origins of our electronic devices can be traced back to the inception of the universe during the Big Bang. Today, this essential element plays an integral role in powering our modern world and shaping the future of technology. We hope you enjoyed this awe-inspiring voyage into the history of lithium. Join us next time for more exciting adventures in the world of science. Till then, be curious and keep exploring the wonders of our universe. Do let us know your thoughts in comments and keep watching Viomology. Thank you.